Hello. In this video, I'm going to talk about arithmetic sequences. In particular, the use of the formula for the nth term, as shown here in the syllabus. The formula for the nth term of an arithmetic sequence is given on page 3 of your formula booklet, as shown here. A number sequence is an ordered list of numbers defined by a rule. The numbers in the sequence are called the terms of the sequence. If you look at the example shown here, the first or the top row has 3 bricks, the second row 4 bricks, the third row 5, and the fourth row 6. So the number sequence of bricks is 3, 4, 5, and 6. The nth term of a sequence is the value of the term which is in the nth position in that sequence, and the nth term is denoted with the symbol UN. So in the example shown, 3 is the first term, so U1 is equal to 3. 4 is the second term, so U2 is equal to 4. 5 is the third term, U3 is equal to 5, 6 is the fourth term, so U4 is equal to 6. The formula for the nth term of a sequence is a formula that states the general term of the sequence, UN, in terms of n, the position of that term. For example, here the sequence starts with 3 and we add 1 each time, and the formula for the nth term is equal to n plus 2, as can be verified by these calculations shown here. So once we have our formula for the nth term, un, we can use this formula to find any term. For example, to find the 20th term, u20, replace n with 20, so that's equal to 20 plus 2, 22. An arithmetic sequence is a sequence in which each term differs from the previous term by the same fixed number. This fixed number is called the common difference and is given the symbol D. In this example, each term differs from the previous term by 1. So the common difference D is equal to 1. In general, to find the common difference, you need to subtract consecutive terms, as shown in these two formulas given here. However, in practice, you will probably subtract the first term from the second, or the second from the third, or perhaps the third from the fourth. The formula for the nth term of an arithmetic sequence, as given in your formula booklet and quoted here, is un is equal to u1 plus n minus 1 lots of d, where u1 is the first term and d is the common difference. The diagram shown here is to help illustrate this formula. In this first question, we're asked to find the 10th term of the arithmetic sequence given. We can start by writing down the first term, which we're told is 7, and then adding on the common difference of 8 will give the second term, u2, which is 15. Adding on the common difference of 8 to the second term will give a third term, u3, of 23, and adding on 8 to this term will give a fourth term, u4, of 31. Continuing this process will give a 10th term, u10, of 79, as shown. These simple calculations can be done neatly on your calculator. From the main menu, if we choose Run Matrix, which is option 1, and then press 7 and press execute to enter the first term. And then if we add the common difference by pressing add 8 and execute again, we'll get the second term of 15. Now simply pressing execute again will give a third term of 23. And pressing execute again will give a fourth term of 31. And if we keep just pressing execute, keeping track of which term we're calculating, eventually we will calculate the 10th term. So as before, the 10th term is 79. Now this method wouldn't really be appropriate if we had to find the 100th or even the 500th term. And looking at the glossary of terms, we see that find is defined by obtaining an answer showing relevant stages of working. So for a more mathematical approach, if we use the formula for the nth term as given in your formula booklet, and if we substitute in the first term u1 of 7 and a common difference of 8 as shown, and if we simplify the algebra, we will get an nth term formula un equal to 8n minus 1. And then to find the 10th term, we simply replace n with 10, again giving a value of 79. In this question, we're given an arithmetic sequence and we're asked to find the number of terms. So if we start by writing down the first term, which is 55. Then if we subtract consecutive terms, for example, the second term u2, take away the first term u1, we see we get a common difference of negative 3. And the negative indicating that the terms are going down, decreasing. Then if we use the formula for the nth term, again given in your formula booklet, replacing u1 with 55 and d with negative 3. To find the number of terms, we're going to use the fact that the last term is negative 38. We're going to write an equation by equating un to negative 38. Solving this equation will give us n, the number of terms in the sequence. We can either use algebra to solve the equation, given a value of 32 as shown, or we can use solver on the calculator to solve the equation. And to do that, if we go back to the main menu and select equation, then if we press F3 for solver and F2 to delete any previous equation and F1 to confirm that deletion. So if we type in the equation we want to solve, starting with negative 38, and then the shift to access the equals, 55 plus bracket, and we use x for the variable, take away 1, close the bracket, times by negative 3. And then press execute to enter the equation. Just note that the number next to x is not the solution to the equation yet because we haven't pressed solve. This is just the number that's left in the calculator from the last time the equation solver was used. So to solve the equation, if we press F6, we'll see that x, or n in our case, is equal to 32. So the arithmetic sequence has 32 terms.